All right, we're going to go ahead and look at horizontal asymptotes because when we look at limits as they go to infinity, horizontal asymptotes are what tells us how the graph behaves at the very end. So that's why we look at that end behavior. So there's three situations. One is when the numerator degree is less than the denominator degree. Okay, so this is usually talking about degree and degree. And what is happening in that case is that there's a horizontal asymptote at y equals 0. Okay, what I'll say about this one is you can remember these facts, but I think it's easier just to logic through or think through it, okay? So typically, we would look at this example, and it's our limit as x goes to infinity of 1 over x. So as you guys know, the first instinct when you're finding a limit is to go ahead and plug in what it is approaching. So if I plug in infinity for x, I have 1 over a very, very, very large number. If I even go on my calculator and take 1 divided by 5,000, it's 2 times e to the negative 4th. So what that would mean is 2e negative 4. What this means is 2 times 10 to the negative 4. So you take your decimal and move it over 4 times. So it'd be 0.0002. And that's just by dividing by 5,000. If you were taking divided by 5 million, it'd get even smaller. So it's a number, and what's going to happen to it is you get really, really close to 0. Okay, and that's what happens when your numerator degree is less than your denominator degree. Your second situation is when your numerator degree is equal to your denominator. This is your favorite, okay? So what I would do is take I say leading term over leading term. So it's your biggest degree over your biggest degree, but you take the term in front of it as well. Okay, so if we had our limit as x approached infinity of our function here, we'd have 2x squared over x minus 4x squared. We would go ahead, we would take, 2x squared and negative 4x squared. To find the limit, you take your biggest degree, and then we always simplify. Okay, so this would be negative 2 over 4, which is negative 1/2. Okay, so there is that. So that would be our asymptote at y equals that number. It's also our limit. Then our third situation is the numerator degree is bigger than the denominator degree. So our degree in the top is 3 here, and the degree in the bottom is 1. Okay, so if this is the case that we have our limit as x approaches infinity. We always start out by taking our leading term over leading term. So I'd have x cubed over x, which reduces to x squared. Okay, well, if I think about plugging in infinity for my x squared, I should technically write my limit here. I would have infinity squared. If I take a very large number and square it, it's just going to get even bigger, so it'd just be an infinity. Okay, the other way you can think about it is if I have an x squared function, they look like this. Are there any horizontal asymptotes or anything? No, there isn't. And then as we look towards, as x goes to infinity, so as I look this way, what happens to my y values are going to continue to go up. Okay, so that's your third situation. Let's go ahead and end this video here. We'll pick up on the next one.